Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so I'm presenting the different side of things, which is to say, why are we partnering with this Surface device from MSR? We've actually been looking at touch-enabled platforms for quite a while. And even before I get to this fact that we've had a long line of researchers doing this, Roy did say that we had this RFP. We actually expected something like 40 proposals. Maybe that was a little naive. But he said over 100. We had 115 submissions from 25 different countries, and we were only able to accept 10 of them. And that shocked us. And first of all, we had to bring on a bunch of other reviewers to do this whole thing, and it was quite the task. And what I was hoping for, and I got involved in this fairly early on, I was hoping that we can really look at this as a new model for interaction. And there's not that often that we can get Microsoft as not the research part, but to be able to give to academia and also have that tie into the researchers working with the external researchers. So that's one of the reasons that I'm excited about this summit, is that we're actually pulling everybody together. I hope there'll be a lot of questions and answers. Having Dave here means that people can say, hey, I'm having problems with this, or how do I do this, or what's going on? And likewise, they can share and get people here excited about this is a nice model to encourage innovation in this space. So that's really kind of why I'm excited about this. So just as an overview, there's this long line of researchers and long line of projects. We're just going to actually demo 2 in this session, and then Dave's going to demo something later on. Let me just start getting to it. Ken Hinckley has done this work probably for 20 years. I mean, this is really what his thesis was about, and he's really explored this space of touch interaction. And there's a variety of devices and collaborators. Of course, we also have Bill Buxton working on it, and he's been exploring it for 40 years. So there are devices. He's been particularly interested in multi-hand devices, pen and touch, really pushing the fact that pen is not sufficient and touch is not sufficient. But if you use them both in combination, then they're all that much more compelling. We have all sorts of different sensing techniques and standard, I would say, user interface tropes like magic lenses. But how are those magic lenses enhanced when you're using a touch-based device? This is actually some of the newest work. It involves sensing things off of the surface. This was presented at Chi this year. And it actually was mostly for the phone. But there's lots of potential saying, I'm moving up to this device. Let me just start putting some user interfaces on there. And let me not crowd the user interface when it's far away. But when I can touch it, then I can put some user interface up. That's particularly intriguing. I'll come back to this and give Michel a chance to speak. One of the reasons why we wanted to actually demo this one in particular was that this technology was actually used in a demo in collaboration with Dave to do some visual analytics kinds of work. So we really wanted to focus the things that we're talking about here on not just general touch, although that's interesting, but touch and visualization. So this is probably not the earliest one, but one of the early ones that I know of was actually not on a Surface Hub, but on a Surface. It was actually originally called a play table, but it was a tabletop device, and there's been a lot of tabletop device for doing visual analytics. And this was work by Petra Eisenberg and Daniel Fisher. I know a lot of you know them. And it was really about analyzing large collections of things collaboratively. And that's one of the exciting things about these large displays, is that they're great for collaboration devices. Bangshin, and I had changed this, so this is, there we go. Bangshin has done a ton of seminal work in this space. I find it particularly exciting that she's taking this concept of making this device sort of intelligent, be able to look at your gestures and turn them into charts, visualizations, and presentations. And that's, to me, a particularly intriguing aspect. And anybody who sees this kind of gets that notion of the magic that goes with having a device that's digitally connected, understanding what you're doing, and being able to empower you to do more things. She's also done some work on surfaces with Sheila here and others. Just, again, the fact that you can tangibly interact with the data really seems to fundamentally change the overall feeling of that interaction. I did some work with Daniel and Sumit about, again, that intelligent notion. This was a project called iCluster, where we were taking lots and lots of different documents, sorting them into collections of things, and trying to essentially build machine learning models so that you could take a document and say, what cluster does this belong to? And yes, you have this sort of affinity diagramming where you sort of take lots of Post-it notes and stick them, but very quickly you start saying, well, what's the best cluster that this belongs to? So you can click on this and it just draws an arrow from one of these documents to a cluster. Or you could click on a cluster and saying, what are the things that best belong in here? And we found that people could sort anywhere between twice as fast to 10 times as fast with about equal accuracy on these clustered collections. So it was pretty exciting. We haven't followed that up for a while. I'm going to do a demo of Sandance. I feel like you can pull a string at the back of my neck and let me go, and I'll do this. I've done this so many times. But I was surprised, actually. I was talking to Chris Collins, and he said, oh, I hadn't seen this. And since this is a relatively small group, I can do a quick poll to see how many people have seen Sandance, or how many people have not seen Sandance. That would be better. OK. Okay, see you live there. Okay, so I will do a quick demo of that. And at the end of in the afternoon, Dave's going to be showing, in some ways, a similar system, but with a different emphasis on 3D interaction and even looking at ways of augmenting it further. So, yeah, I'm getting to the demos, really. So Sandance, actually, we shipped this in late March in two ways. One, there's a research website that you can just go to and try this all out yourself. We have a sort of guided tour that will step you through it. And it's also available in Microsoft's data analytics platform, Power BI. One of the things Power BI is really focusing on is extensibility. So you can wrap custom visuals of any sort and make it available in the Power BI workspace. And this is kind of nice. A big competitor is Tableau. Tableau is fabulous. It's got a lot of things, but they don't let you create new kinds of visualizations in there. And that's something that Power BI is really trying to push a lot. So Michel showed collaboration. Sandance has some collaborative aspects, but what I find it best for is sort of storytelling with data. There's an exploratory component and a presentation component. They all kind of work in conjunction with each other. And I found some of the best ways to communicate insights to people is show you how I came to those insights myself. This is a data set that I've used a lot. It's actually hard to find data sets that have interesting insights that are of interest to lots of people. This data set is from the 2010 census, where each point is represented on the screen, and that's the kind of unique aspect of Sandance and some of the other things, these unit visualizations. Each point is represented on the screen, each point represents a county. Actually, it's a sub-county. There are 25,000 of these census-designated places. And I can do arbitrary selections, and I can get details on them. And you can see that with each point or row of your data, we have lots of columns of information. We've got the longitude and latitude. We've got who they voted for in the 2012 election, not about 2016 election. That's pretty important, and we're going to get that data as hopefully before it comes out, because that way you can come here and see the night of it. Since you've got this information, showing this as a grid is not really very useful. And this is one of the aspects of visualization, which is to say we can do more than show it in a grid. We can change the view, and that will give us different insights. So for instance, because we've got longitude and latitude, one of the things we could do is just lay it out on a map. And those were the points that I had selected before. Again, this will run on any device with or without a surface, but you seeing my actions, I think, has a fundamental difference in you following along with what I'm doing. If I'm just switching from one slide to the next, You have to figure out what I did. But you saw that I switched to a scatter plot view. You saw some things. So for instance, if I switch this to a column plot view, you can actually see, okay, that's what happens in a column plot. And we use the animation to express all those points moving down into these columns. So it's that, to me, really helping people follow along is incredibly important. And I do this action a bunch of times because we actually take great efforts to sort the data in such a way so that movement makes sense. This column plot really is just a histogram. It's just counting up the number of points that there are in each of these areas. And I often say that this thing that we started off with is not a map. There's lots of map-based visualization work going on. This is just a scatter plot. It's just showing the things. There are ways that we can layer on a map underneath it, use choropleths, use other technology. But really, this seems like a map because we're so familiar with the positions of the points in the United States. There's also meaning that you can start to glean and understand of this right away. So when I go to this column plot, you can see that it's very sparsely populated out in these areas. And that's because, again, when we switch back to this map, that's because the Rocky Mountains and the desert is not very high populated, so you don't need a lot of counties there. Likewise, when I switch over here it's not very populated. And we can select this and we can watch these things go up and we can kind of understand why it's not very populated. And that's because up in the New England sticks out a fair amount. It's interesting. We have a bias to interpreting things as rectangles. So if you ask your typical fifth grader on this coast, what is the most eastern point of the United States? Half of them pretty much will say Florida, and half of them will say Maine. It's remarkable. But when you see it like this, it really sticks out profoundly. So, of course, just looking at it this way doesn't really mean that much other than their positions. We can start mapping other attributes, other variables on top of this. So if we say color this, I'm going to color this by income. And I'm actually going to choose a palette that is a little bit more continuous than that. Okay, so what we've got, it doesn't look more continuous. We've got red representing low income, and we've got blue representing high income. This is the median income across the United States in 2010. And, I purposely chose these colors. Usually you choose blue to represent low numbers and red to represent high numbers because hot and cold. But I chose red here because it kind of looks like the whole country is on fire here. And it really reflects the fact that this is not a great situation. I'm not seeing a lot of blue throughout this country. You're seeing some around LA, San Francisco, Seattle area, Chicago, around the urban centers. But you're really not seeing a lot of high income. And again, if we were to switch this to a column plot, you follow first where these places were. So this is, again, the LA and the San Francisco area and the Seattle area. In this case, we're not really interested in the distribution of blue based upon longitude. We really might want to say, let's sort this by color. And we can see within each of these regions, there's just a little high income in each of those areas. But what I really want to do is I want to kind of gather up all the low income down here and the high income up there. So if we choose income and do the histogram, poverty levels are right around 26K. All of these counties are living at the poverty level below. And to me, this is just a startling representation of this. It's profound. You see this weight of this graph here on this side. Now, again, these are proxies. Some of these counties have 300 people. Some of them have 3 million people. So it's not exactly the wealth income gap across the country, but it does give you this good idea of it. And what I like, again, about Sandance is that there are a bunch of different related views, that you can see different ways of looking at the same dots, these same information. So if I want to see a correlation with income, I can switch to a scatter plot view and look at different variables that I want to correlate with it. So for instance, I know that unemployment has an interesting correlation with it, which is to say the more income there is, the less unemployment there is. And that kind of makes sense. You could also change income to education. And now you're seeing that the more education there is, the less unemployment. It's actually interesting to actually look at some of these outliers here. So some of these outliers, or some of these points up here, where are they? And I can get the details on those guys. It turns out that the highest unemployment and lowest education in the country is in Apache County, Navajo County, Coconino County. These are all Indian reservations. They all just jumped out from just looking at this graph. And then, that's pretty startling and makes sense as well. One of the nice things about showing all these points in a scatter plot this way is we're actually looking at 3 variables here. We're looking at education, we're looking at unemployment, and in color, we're looking at income. And when we look at it that way, we're getting a couple of outliers right now. And I was attracted to this way back when I didn't know what this was, and I've used this thing so many times that the people all around me know where this is. But this place that has 95% of the people that have a bachelor's degree or higher doesn't make much money. And as I select this, you can say, everybody yell out, where is that? It's Stanford, California, where the median age is 23. This is a college town. And that wouldn't have occurred to me, except it makes sense now. Okay, that's one point, that's one outlier. Well, what about this point? Same sort of situation. In fact, they're making even less money. Where is that? Select that, that's Tompkins County. And going, I don't really know what's in Tompkins County. But if I click on it and I look it up in Bing, we can see that Tompkins County is where Ithaca is, where Cornell is. And it's like, okay, now I'm starting to understand that. By the way, that's kind of interesting because this was outside of this data set. But I kind of have been forming a hypothesis here that high education but low income, so let's switch this to income. So this whole area, these 2 were college towns. Let me actually select more here. And if I get the details on each of those, where are they? Turns out that Druid Hills is where Emory is. We've got Stanford again. We've got University of Maryland. We've got Swarthmore. We've got Cornell. Keep on going. Every single one of these places, these are all Cornell, that's Dartmouth. Every single one of those places is a college town. Now, some people might say that's not the most profound insight. However, this is something that was not in the data set. This was something that I, with my own knowledge, my semantic knowledge, was able to add to it. It's one of the reasons why I think visualization on these surfaces works very well, is that we're bringing our expertise, we've great pattern recognizers, and we bring external information to looking at these problems to help understand them better. There's lots of other demos. This is just one data set. You can use this with all sorts of data sets. As I said, you can try this at home. And we're really experimenting. We're going to get out a next release of this with a lot of the suggestions. Since we've had this out, we've had some reports from Power BI that there's like 10,000 users a week on their version. We're seeing about 1,000 users a week just on the Microsoft website version of this. And it's available in 2 different ways. It runs in a browser, so it'll work on Macs. Right now, this version won't work on iOS, but we're looking into some issues there as well. And really, I think it's exciting to kind of use this as a launching off point for a lot of the kinds of analytics work that we want to be doing. So, come to a close now, and we're actually about 15 minutes ahead of schedule, which is great because we didn't build in some bathroom breaks. And I also want to have a chance to take some questions in general, if you've got those. And if not, we can break. So any questions right now? Chris?
Sort of a question comment. One of the things that I teach about when I talk about this in the classroom is the fat fingers problem, right? And the fact that I'm watching you select these points and you're using a box for a single point. And it works because they're outliers. But if these were right in the middle, this would be really difficult. So I think that's an interesting research challenge that we still haven't solved.
Yeah, I know that John, one of John's students has...
Stephen, sorry, would you just repeat the question for the recording?
Yeah. So Chris Collins asked about the fat fingers problem. In other words, it's very easy to select an outlier here, but if I was trying to get this single red point, whatever point over here, it's very hard to get to. And it is a difficult challenge for doing that. I have seen some work from John and one of his students, Ramek Sedana, who's done sort of magic lens, kind of like zooming into that and then selecting those and pulling out, and some other techniques. I think that's particularly exciting. I know that there's fat fingers problems not just on selecting and interacting with the data, but when you're actually using these controls, you have to make sure that your controls scale to the right level too. And in Dave's demo of NuiVis, you'll see that he's paid a lot of attention to make sure that all the controls have a size that you can interact with effectively. So I think that's great. Annie?
Why not just uniformly use pinch zoom for data and control?
I think it's certainly possible. One of the things that I find is that we do have the ability here to do some pinch zoom well. So if I just do it in this mode, I can pinch zoom. Perhaps I can then do, right now it goes to a different mode. We can select and then we can pinch zoom out of this. And if I do that here, maybe that will work as well. One of the problems right now is just making sure it's a clean implementation. We find that if we don't have it exactly right, we do one selection, we go into different sort of modal way. So I think maybe if you do it just right, it'll help. But I know that John can probably talk about the study that they did.
Once you move to multiple viz techniques, the problem is sometimes some of the gestures, you want it to do one thing in one viz and another, and you get into this kind of, you want to optimize the suite rather than optimizing the individuals. You run out of gestures very quickly. And it's a real challenge. It's a subtle challenge.
Yeah. Good, Dave.
Yeah, so I have a question. If you, so far all this data is shown 2D, have you experimented with rendering it in kind of a 3D layout? And what are the benefits and challenges of that?
So Dave and I had a little discussion beforehand. Sandance does support 3D. We haven't explored it really in depth in Sandance. Dave's been focusing on 3D a lot. 3D in the InfoViz community is an interesting and controversial topic. We have an intern, one of our students, Harry, who's back there, who's actually been looking at 3D this summer, and we're looking at augmented reality in 3D, and we're looking at devices like this in 3D. I call myself skeptically optimistic or optimistically skeptical about this because, when you just have 3D in a static visualization, it's very poor. You get a lot of occlusion, there's perspective confusion, there's lots of problems. But since these things are just so easily manipulated as far as your viewpoint, that helps a lot. It still is a problem to say, I have to change my viewpoint to understand my data. So perhaps as you're starting to do other ways of doing this, perhaps HoloLens and other things like that, will help you automatically do that. I do know that 3D can be very, very compelling, and people get pulled in and excited about it. And there's been sort of arguments. Stephen Few sits on a panel and says, don't give me 3D. And the response is, all of our customers are asking for 3D. And he says, well, you should make sure that your customers know what they're doing with this. And to me, I think the verdict is still out on this. I do think it's a great thing in research to be experimenting with it. It's finding better techniques to be selecting, viewing, and interacting with your data. And again, Dave is going to share some great demos this afternoon on that.
Is 3D hard to implement technically, or it's not?
Actually, no. Nowadays, I mean, well, I won't show you. You can see actually this is rotating in 3D. This is in a browser with WebGL. We've got Unity. We've got SharpDX. There's lots of platforms for doing effective 3D. I started my career with Andy back there looking at graphics packages that were two-dimensional graphics packages, and then three-dimensional graphics packages. I feel like they are so widely available now, and they're taught in undergraduate. I don't know whether you're still teaching your basic rendering pipeline, but that was the ultimate project that we did at the end of the graphics course I took, and now that must be one of the things you just start to know that you can build on top of. So I think it goes pretty far now. And Andrew. Interesting. Animation can be used as a third dimension if you're switching between multiple, axes of your things. Right now, we use animation more to go between different views to show the correspondence. Now,
the point of adding another dimension is to show more relationships between the data, and that is what we're doing. So in that sense, it's functioning that way.
Yeah, I mean,
I'm going to disagree with that. He uses animation to provide. He uses animation to provide continuity between two different views, because Brenda Laurel and other people at Apple showed that it's much less disruptive when you have animation as a transition than when you have a jump cut, in effect, between one view or another. Using animation to show a third dimension is quite a different visualization technique, and it's quite difficult to apply in a intuitively obvious way for the user.
Yeah.
It's a good dimension, but it's fraught.
It depends on, conceptually, I'm not saying literally, because it's a multi-dimensional space, and that continuity it's helping you out. In that sense, the animation is kind of functioning as a dimension. But it's fine for us to disagree about this. I don't have a problem with that.
We can take that offline. It is true that we've had studies of the Hans Rosling type of animated through time visualization work is very eye-catchy, but if you're actually doing a task, small multiples often work better, and John was on that work, and I think Bongchen was on that work as well. So yeah, I really find animation compelling, but if it's used in an explanatory concept, and I think both of you are saying that, trying to do that is effective. Anything else? Let's give us a 5-minute break.
So, no surprise, an hour in, we've had our first academic debate. I'm very happy to see that, and also that we're able to sideline that for another time. I would also very much like to thank Stephen as he finishes up his opening remarks. He's been a terrific champion and teacher to me as I've been learning the landscape, not just around Microsoft research, but around the academic research community, and has really been kind of an ideal partner for me in figuring out how to work with folks like you who are way smarter than I ever expect to be. So we'll take a short break, our first break of the day.